a question, right, Jim? All right. We're talking about evaluating the inverses of trig functions. Okay. We have talked about inverses before, but that's the thing where we switch the x and the y, right? So really the official definition is that if we have y equals arc sine of x, if we only have the sine of y equals x. We talked a little bit before. Splash talk's not working? Try again. Now it's working. Okay. Good then. Okay. Yeah, and I thought maybe it might have been that, and then I've had weird things like I had loving Aries post today. Somebody had loving post the last 2 times for the it's the internet. Okay. So we've talked about the inverse before, okay? We did some problems when we were doing the angle of elevation, angle of depression, where you had to find the angle. That was inverse trig, okay? Basically inverse trig is solving for the angle versus solving for the sides, okay? You can write it a couple of different ways. This is presenting it as arc sine. You can also write it as sine inverse. This is the way it's in your calculator. Desmos, you can type in either one. Okay, I played with that a little bit. You can see you can do either one. Okay. There's a couple of little issues, and we're going to talk about that with this on domain restrictions and range restrictions that we have to comply with. First of all, if we had done the graphing, we would understand this piece. We'll understand a little more as we see the graphing. But you only can go between -1 and 1. Hopefully you saw that when you did the little exploration thing this week, the project this week. That the highest point on that graph was 1, and the lowest point was -1 for sine and cosine. Okay? Not true for tangent, but for sine and cosine. But it also has some issues when we talk about the range and where we're allowed to have values. Yesterday we were allowed to go anywhere from 0 to 2 pi, or 0 to 360. Today we're working strictly radians. Okay? So with arcs and inverses, we are not allowed to do that. Okay? It's because in order for it to be a function, we have to restrict it. We take the function restriction off it. Okay? So over here on this left side, write the words valid and I'm going to explain what quadrants it is valid in. We have to identify that first. Okay? So, look at what the range says. It says it's going from -pi/2 to pi/2, meaning that I've got to go from here to here, which is kind of weird. Okay? And let me explain why. What they're trying to get at is, you know how we had 2 answers yesterday? There were always 2 places where I had a +1/2, and always 2 places where I had a -1/2. Well, when they're doing the inverse trig, they only want 1 positive and 1 negative value to be true for it to be a function. So they choose 2 quadrants where the sign is positive in one and negative in the other, and the quadrants are next to each other. Does that make sense? Okay. Same thing with tangent. Tangent's positive here and negative here, so it's valid in quadrants 1 and 4. So I would write that this is valid in quadrant 1 and quadrant 4. Okay. Cosine's a little bit different. Cosine, if I did 1 and 4, it would be positive, positive, right? So cosine would be quadrant 1 and quadrant 2, because, and it goes from 0 to pi. Because that way I get one set of positive answers and one set of negative answers. So this one is 1 and 2. If you can remember, it's always 1 and 4 except for cosine. You'll get it when you get this on the test. There's also something else funny I did here, and we need to make some adjustments to your unit circle. You see how we started it with negative pi over 2? What is on here on your unit circle? What does it say down there at the bottom? It says 3 pi over 2. So if I were to put that on a number line, does that number line make any sense? It doesn't, right? Because I can't count from positive pi over 2, 3 pi over 2 to 0 to pi over 2. But remember when we talked about coterminal angles? I can, exactly, if I subtracted the pi over 2 pi, which is the same as 4 pi over 2, don't I get negative pi over 2? So it's the same thing, it's just another name for it, it's the coterminal name, and it makes much more sense now to go from negative pi over 2 to pi over 2. So what I'm going to allow you to do is we're going to make some adjustments to the unit circle. Put 3 pi over 2 comma negative pi over 2. We did that same adjustment for everything in that fourth quadrant. So the 11 pi, I need to draw it so you can see it. The 11 pi over 6 should be comma negative pi over 6. You can write that on. Okay? Don't erase the 11 pi because you need it for other things, right? But in this context, when you see the arcs, that's when you know you have to use the negative ones. Okay? And then let's see, 7 pi over 4, is that right? Should be negative, or is the same as negative pi over 4. And then the other one is 5 pi over 3 is the same as negative pi over 3. So when you're giving me the answers in quadrant 4 today, those I should see, I want to hear the negative answers. Okay? Not 5 pi over 3, 7 pi over 4, 11 pi over 6. Correct. Yeah, because remember how we counted the wedges one day? If I count up, I go positive. If I count down, I go negative. So yes, it is very much a order. Yeah. Negative pi over 6. Okay? And again, make sure you got it. Again, you have to make sure they're written right? Because we're going to use this for the test again. Okay? Not taking it away yet. Okay, good. Because I'm going to go to the next screen where I try some problems. So, almost try some problems. This is what the pictures look like. I don't need you to know what the pictures look like for inverse. I've never seen them really anywhere. Okay? Of course, saying that for sure, like senior year, they'll be on your AP test. Just watch. But because of it being a function, you have to stop the range or the domain there. It stops here. And you will even see that when you put it into Desmos. Notice there's endpoints on it. Tangent, not so much. It keeps going. Okay? That's all. Just, they're graphs that exist. That's how you know there's one there. Okay. Yeah. All right. So yesterday the problem looked like this. Same problem. Solved it pretty much the same way, but it looked like that. Today it looks like this. The difference is this has 2 answers because yesterday we were working 0 to 2 pi. Today we only have 1 answer because of the arc, we put that restriction on it. Okay? So, I'm going to walk through what we did yesterday kind of in order to work our unit circle backwards to get the radian measure. Okay, we're going to practice that a few times, then we're going to move on to kind of going both directions with it. Okay? Alright, so, arc sine, what quadrant did we do? Quadrants did we just say it's valid in? 1 or 4, okay? It looks like we need the negative ones. Which quadrant am I working with? 4. So I know I've got a 4th quadrant. We're going to assign the x value or the y value. Okay, so look in your 4th quadrant, look for the y value to be negative 1/2. That's the radian measure. Okay. Degrees are almost dead to us, Cameron, okay? We're getting to the point where we're going strictly radians, alright? Making that transition. Alright, so today we're doing radians. You were correct, but not correct. Okay? We'll do right spot with the wrong answer. Okay? Alright, we good with example 1? Alright, let's look at the next one. That's it. Lots of thinking, not a lot of writing, right? That's just part of trig. Okay? Alright. Sine is valid in which quadrants? First and fourth. This time it's positive, so which quadrant do I want? First, is sine the x value or the y value? So what radian measure is the y value positive square root of 3 over 2? Pi over 3. Okay, they see it? Okay. Look at example 3. What quadrants is sine valid in? 1 and 4. This time it looks like we're looking for positive. So it should be in the first quadrant. Alright, is sine the x value or the y value? The y value always. Okay, look for your y value to be 2. No. Okay, remember I boxed this on that first slide? Your x value has to be between negative 1 and 1. So what are we going to say about 2? It's undefined, yeah. And if we had done the graphing lesson, you would probably pick that up. But that's okay. So you know it has to be between negative 1 and 1. So what am I writing? Undefined. And it's because, and I would write the because this is the notes. On the homework, you don't have to write the because. Okay, because 2 is outside the domain for sine. Or you could use 3. Okay, so those would be, it's probably not going to be anything on there. Okay? And if you put this, we'll do one in the calculator in 2 minutes. You'll put that in the calculator and come up with an error score. Okay? Good to 3? Alright, so we're going to switch to cosine now. Alright, which quadrants is cosine valid in? 1 and 2. Which one is it positive in? Okay, is cosine the x or the y? X. So I want an x value. I want where the x value is positive square root of 2 over 2. What's the radian measurement? Good. Looking at this one here. Cosine inverse, which is the same as our cosine, which quadrants is it valid in? 1 and 2. 1 and 2, good. Alright, is cosine the x or the y? X. So I need the radian measure where x is equal to negative. Okay. And now we're moving to tangent. Now you notice we're only working sine, cosine, tangent of these. We didn't give you the inverse trig on the other 3, though it does exist. Yes, I need to go back. I think so. I know my. Why we're in quadrant 2? Okay, so for quadrant 2 for cosine, if I were to do quadrant 1, what that is cosine positive or negative in quadrant 1? Oh, positive, right? And then quadrant 1, okay, is cosine positive or negative in quadrant 4? Positive. So I don't get any negative values if I use those two, but I get a negative value if I use there. And I want to be continuous, right? I want it to be 1 grade. Okay, does that make sense? Alright, good? Alright, it's okay. Alright, arctangent, so which quadrants is tangent valid in? 1 and 4, good. We need to do 0, right? But 0, tangent is what over what?
Sine over cosine.
Sine over cosine, so this is really saying that the sine is 0 and the cosine is 1. There's always a 1 in the denominator. So I'm looking at the point 1, 0.
2 pi.
Alright, I heard 2 pi.
Wait, why is it not 2 pi?
Okay, it isn't 2 pi, but I'm going to explain it, okay? So here's the reason. Think about our number line again, right? It's got to go between negative pi over 2 and pi over 2, right? Can 2 pi be be in between there?
Okay.
Do we get it now?
Yes.
Right, what is in between there though? That is the same as 2 pi, right? We always forget that when we start counting on the unit circle, we start with 0, right?
Can we
And
put
it's
that
both 0 degrees and radians. Yes, what was the question, Cameron? Got it?
Yeah.
Okay. So my answer to this one is 0. And today, if you really wanted to be specific about it, you could write the word radians after it. You don't have to write it with 0. Alright, good with 6? Alright, 7. Okay, so it's getting trickier again. Now I've got tangent of -1. What quadrant is negative or is tangent valid in?
24.
1 and 4. Okay. Which one is it negative in?
4.
4. Okay, so let's think about what that's really saying. That means I need the sine and the cosine to equal, the sine over cosine to equal -1. Go get your coordinates in that, it's like this, like that one, right? Is that right? Did I get this one right? Other than the negative on it?
Yeah.
Yeah, okay, and then it is 1/2 squared root of 3 over 2, that, right? So, if I were to take and I put 1/2 over square root of 3 over 2, is that going to reduce to 1? No. If I do this one, is that going to reduce to 1? No. But if I do square root of 2 over 2, square root of 2 over 2, is that going to reduce to 1?
Yes.
Yeah, so it's got to be this radian measure attached to that one. The ratio, basically the sine and the cosine have to be equal except for the sine. Okay? The plus and minus thing. So it's negative pi over
6.
4. Cameron, is your circle set up right?
No, I can't read my writing.
Okay. That is a problem.
But I can read it, but if I'm like trying to write.
Yeah, because we keep giving me the
I'll figure it out.
All right. David. Why does what? Because I need to reduce to -1. And the only way that these ratios, see how this one here, it doesn't reduce to 1. That sine over cosine doesn't reduce to 1, and this one here is the same number over the same number, so it's reduced to 1. If we look at the tangent is the sine divided by the cosine. I can't do quadrant 2 for tangent. It's not valid, it's only quadrant 1 for 4. I know, but the rule is written by the powers that be, right? Powers that be. So one of those heads over there that invented this, right? One of the mathematicians, it says I can only go negative pi over 2 pi over 2. Does that make sense? You only are allowed to do this according to the definition. Okay? Correct. Yeah. Right there, yeah, just there. Okay? But yes, you're right. In theory, it should work the other way, but it doesn't. Okay? It's only on tangents kind of. All right, let's keep going. All right. Oh, good. The hardest problem on the page. Okay. It says we get to use our calculator to approximate that value. All right. So our calculators are open, right? And on. First thing I want you to do, go ahead, Doc B, clear what's there, so you're honest about doing this. Okay. Double check to make sure you're in radian mode. My guess is most of the calculators are there at this point. Not get it set in radian mode. You also want to check or make sure. Somebody was, we noticed it in calculus the other day. We're having issues with our answers to calculus. On this display digits thing, you guys, don't switch it to fixed. Keep it in the floats. Okay. Because then that way it rounds it, or you don't get it rounded weird. And calculus floats into an insane amount of numbers because we need a lot of numbers to be accurate with our answers for our AP test, okay? You need at least to have floated to 4 because we want to be accurate to 3 decimal places, okay? You don't need to mess with it if it's tab. I don't know why, but that's there. All right. So arctangent, we're gonna do arctangent negative 8.5. So we're gonna do trig, and it's, remember, its arctangent was written as tangent inverse in your calculator, and it was negative 8.45. Enter. Write down up to 3 decimal places, right? I think this might be too hard to put on the next test. Yeah? I think we just put like 5 with those on. What was the number again? It's a negative.
453.
Negative 1.453. Okay. Okay. Yeah. So, on tangent, I can go negative. You get it here. Alright, try 9 and 10 right now. On your own, I'm not going to do them for you in the calculator. Try them and we'll write them down. What? Too hard? Okay. What did we get for 9?
0.247.
0.247. Alright, 2.247. Alright, what happens with this one?
It doesn't work.
It doesn't work. That funny error screen means that it is undefined because it wasn't between
1 and 2.
negative 1 and 1, right? That only has to be negative 1 and 1 for sine and cosine, not for tangent. Okay? Alright, good news. We're skipping 11, 12, 13, and 14. Let's go to this right here. We don't need anything that looks like that till BC, so we're not going to worry about it. And even then, I don't know that I really use it because okay. I'm going to show you what was just happening with those two calculators so you guys can use it just in case. There's another weird spot. Show you something you don't know. Alright, we got it all written? Not yet? Okay. In your calculator really quick, okay? We usually go here, right? Settings, dock settings, and then we adjust it here, hit make default, click OK. There are some times where it gets off in the scratch pad, and you put that little triangle down, you arrow up to that. There's another settings and status. There's another dock settings, and sometimes it will get off in here sometimes. And I don't understand why it's different, but it is. Okay? So if your calculator ends up if it's rounding weird or the angle measure isn't changing, that's probably what's going on. Okay, we just had 2 in the room that was doing that. Someone in one of the classes is messing with something. Okay, if they're not paying attention. None of you. Okay, never, right? Okay, let's talk about what these guys mean. Inverses and function composition always go together. Okay, and I think you guys will actually probably find these problems kind of interesting and just a little bit challenging. Remember when we talked about the definition of an inverse? When we talked about it in terms of function composition, when you compose one function with another, it has to equal x, right? We talked about that a couple months ago at the beginning of the semester. It has to equal x. Okay? So, when we compose sine with arcsine, it is equal to x. And when we compose arcsine with sine, it's equal to y or x or whatever it's supposed to be. Ultimately, what that's saying is sine and arcsine cancel out and you get whatever's on the inside, provided it fits the values that are in here. Okay? Alright? So we're going to do a couple of examples that do that, and I think these might also be too hard for the test. Okay? Alright, so the cosine of the arc cosine of 0.8 is 0.8. Okay? I think it was harder than the last one, right? Okay. This one here, I think yours says pi, right? Which I think is a typo because it's still outside the domain. It really should be like pi over 3, right? It's in the wrong part of the domain. Okay, so if it was in the right part of the domain, what happens? Cancel, and we end up with pi over pi. Okay? Or whatever it is on the inside there. Alright, the next problem, that's enough of those. We're going to change to something different. So you'll notice, okay, so here's where it gets tricky. So you need to really pay attention right here. Okay? You'll notice that I now have an arc cosine and a tangent. I'm not just crossing things out. Okay? I'm going to have to use my unit circle in 2 different ways. Okay? And out of the next kind of 6 examples, these first 2 are the hardest. Okay, to undo. The rest of them are a little bit easier as we go through. Okay? So, first thing, when we do composition of functions, remember we always work from the inside out. So first thing I'm going to do is I'm going to evaluate tangent of pi over 4. We have our unit circle. Pi over 4 is here, right? I'm going to square it in 2 over 2, square it in 2 over 2. Tangent is what? Sine over cosine, which means I have square root of 2 over 2 divided by square root of 2 over 2, which is 1. You're going to hopefully get really good at the fact that tangents of over 4s are always in the 1 somehow, right? Yes. Yeah, so it's square root of 3 over 2, yeah, so it has to be the same over the same. Okay? Alright, are we ready to move to the next part? You can use your triangles, that's fine. Okay? But you have to have your triangles memorized in some point. And what's easier to memorize, the coordinates or the triangles? Okay, the coordinates I think are easier to memorize. So I always go off the coordinates and remind you of calculation. Okay? So no, just know where you're headed. Okay? On the test, I'm not going to be able to tell which one you're doing. Okay? Alright, now look at this piece. This is now saying I need to find the arc cosine of 1. Remember, I substituted that in. Okay, so tangent of pi over 4 is 1. I now need to find the radian measure. So, which quadrants is our cosine valid in?
1 and 2.
1 and 2. So now we're going back to what we were doing at the beginning of the lesson, right? Is cosine the x or the y? The x. Okay? So you need to look at quadrant 1 and 2, and we are looking where the cosine is equal to 1. Zero. Because can I have? Oh, I see. Because it has to be between 0 and pi, and 2 pi is definitely not between 0 and pi. Okay, everybody okay? Do I need to explain it again? Alright. So your x value has to be 1. The only it's at that specific pi over 6, right? Okay. Arc sine is valid in which two quadrants? First and fourth only for positive and minus 1 or 2? 1. Okay. Am I looking at the x value or the y value? Y value. So what's the radian measure at 3 pi, where the y is square root of 3 over 2? Pi over 3, it has to be in quadrant 1, it can't be negative. Okay? What signs it? The arc sine is 1 and 4. And when we put the arc on it, then we put the restriction on it. Okay? So we want the tangent, arc sine and arctangent 1 and 4, arc cosine 1 and 2. Okay? Alright, let's keep going. So now it changed. What changed? The switch. The arc is on the inside versus the outside, right? So I'm going to go backwards and find the angle measure first. Okay? What quadrants is cosine valid in? 1 and 2. 1 and 2. Okay? So, and it's positive, so am I going to go 1 or 2? 1. Okay, so what angle measure is the x value for cosine? 1/2. Pi over 3. And so that coordinate is 1/2 square root of 3 over 2, right? Now I need to know what the tangent of pi over 3 is. What do I do for tangent? Good, which is square root of 3 over 2, 1/2, which is? Square root of 3. Square root of 3. Okay? Pi over 3. So I look for my arc cosine, right? The x value. And I look for my x value is quadrant 1. It's 1/2. And then I read the radian measure off that line. Yes. Working radian measure. Okay. Go with 19 because I'm going to 20 is similar. Your x value, not your y value. Make sure you have your unit circle written out right, okay? Okay? Alright. Let's look at 20 here. Okay, so I'm looking at arctangent again, what quadrants is it valid in? 1 and 4. This time I'm negative. What quadrant am I working in? Fourth quadrant. Okay. I need to figure out C. It's sine over cosine. It's really negative square root of 3 over 1, but what is always in my denominators for 2? So I'm basically kind of reversing my simplification, right? So this is saying that I have to have 1/2 negative square root of 3 over 2, especially if I'm in this quadrant, I know the sign has to be negative, right? Alright, so what radian measure does that have? Negative pi over 3. Good. Now I need the sine of negative pi over 3. What's that? I think that direction is easier than the first one. The first two rows. Right? Because it kind of pops up. Okay. We're going to change it one more time. Okay. We all ready up there for 20? Okay. So we're going to find the exact value, but notice, it's 3/4 on your unit circle. No, so when we're not on our unit circle, we default to going back to a triangle. Okay? And this one is really weird. I wasn't going to teach it, but it's kind of mixed in with all the others in the homework, so I'm going to teach it. Okay? So I'm going to start by drawing my triangle. Okay? And in SOHCAHTOA world, what is tangent? Did you see why I have to say SOHCAHTOA world? Because we now have sine over cosine and half of 1 answer, right? Alright, so opposite over adjacent is 3 over 4. What does that mean the hypotenuse is? 5. And if I don't know that, what do I use? Pythagorean theorem. Good. Okay. So, this is the way, at least this is the way my brain thinks that what this question is asking us to do. And I'm going to write it down, and you should probably write it down too. This question is saying find the cosine of the triangle for arctangent of 3/4. So I need to find the cosine of whatever triangle is associated with this. I don't need to go back and figure out what the angle is, I just need to find the cosine of its triangle. When we were able to do the unit circle, we can figure out the angle. It's hard to do that with this, because I'm going to use the calculator. Okay? So, what is the cosine of that triangle?
4/5.
Right. But you wouldn't know to think of this unless we wrote it down, right? Alright, got it? It's weird, right? It's really weird. And it's not something that I tend to see in calculus, so I'm just gonna skip it, but again it's in there. So I'm just gonna go with it. Okay? Alright. Alright. What is so I gotta do my triangle again, right? Let's talk about last time it was positive in there, right? It was a positive 3/4. I didn't have to mess with sign, like plus or my minus. I had to mess with my plus and my minus this time, so just think about where we're at here. What quadrant is our cosine valid in?
1 and 2.
1 and 2, right? It's positive here and negative here, right?
Yes.
And so if we're going to talk negative, we know we're definitely in quadrant 2. What is cosecant in quadrant 2? Is it positive or negative? So I'm going to do with that first and then deal with my triangle. So I know that I've taken care of that. I know that it's going to be a positive answer. Okay? Alright, I know my what's our cosine in subtotal?
Adjacent over hypotenuse.
Good. So adjacent is 5, hypotenuse is 13. My other leg is
12.
Alright. So we're now talking about what is the cosecant of this triangle, the triangle represented by that. 13 over 12. Cosecant is hypotenuse over opposite. Okay. Well, I wrote what I heard, and I thought my brain processed it, right? Okay. Alright, we good with that one? Good news, that's the last one we're doing. Okay? Happy Friday. What? I don't think we need to. We're not going to mess with you very